Alright guys, so we're going to work on section 4.7 vertex form and transforming quadratics. So we already know one type of quadratic equation. That's a standard form quadratic equation, which is ax squared plus bx plus c equals 0. Now, we know how to solve these guys by factoring, splitting, and solving, or maybe even completing the square. Not only that, sometimes we could look at this as a y equals. I hope you guys remember this from a long time ago, if we ignore the equals 0 over here. So if you have the equation y equals ax squared plus bx plus c, you could find your vertex. Remember we used to graph these guys? You would find your vertex. How do you find your vertex? By doing x equals negative b over 2 times a. Alright? And what you would have to do is take your a value from here and put it right there. Take your b value from here, put it right there. Work this out, get an actual number for x, and you would plug in the number for your vertex. You would take that number and plug it in inside of the x values to find your y value, and that's how you get your vertex y value. It was a lot of work, okay? So what we're doing today is actually learning of a new form, which is a vertex form. It's y equals a parentheses x minus h squared plus k. Okay, now this is called vertex form. Okay, why is it called vertex form? Because the h and the k are your vertex. It is your vertex. Okay, so up here on this one, you had to do a lot of work to find your vertex. You had to do x equals negative b over 2a, and you had to plug it back in. You had to do a lot of work. Right here, whatever you see right here as your h and right here as your k, you could find your vertex. So let's just go to an example. Y equals, let's say the a value is 1, parentheses x, let's go with a minus 3 squared plus 1. Okay, this is a vertex form equation, and I could automatically find my vertex. My vertex coordinate, remember the vertex is the most important point, the highest point or the lowest point. So the vertex here would be positive 3 and positive 1. Now you're probably thinking, wait, why positive 3? There's a minus sign right here. Well, the thing is, the original vertex form has a minus h. And the minus implies that you think opposite of whatever you see here. So whatever you see here, you got to think opposite of, and that'll be your h value. Okay? This is your h value. This is your k value. So you always have to think opposite on h. Anyway, why is this form so awesome? Because if you already know, but just by looking at it, that your vertex is positive 3, positive 1, then you can actually go to the coordinate 1, 2, 3, 1, put a dot right there. Not only that, we've already learned this from the past, that if our a value, you guys remember this, if our a value is 1, so there is no number out here, so you could say that there's an invisible 1 right here. If your a value is 1, then it has the pattern of 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9 from the vertex. So that would mean that you'd go 1 over, 1 up, and put a dot right there. 2 over from the vertex, 4 up, and put a dot right there. You could map them over to the other side. We also talked in the past about the axis of symmetry, right? It's that vertical line going right through the vertex. Kind of came crooked. So if you go from the vertex here, 1 over and 1 up, you're right there. If you go 2 over, 1, 2, and then 4 up, you're up here. So you end up with this part of the parabola. Okay. And then if you map it over on the other side of the axis of symmetry, you'll get the same curve. So you end up with the parabola. So knowing vertex form is awesome because you'll be able to just look at it and be able to say, oh, my vertex is positive 3, positive 1. Now, if this would have been a positive 3, then my vertex would have been negative 3, positive 1. Always think opposite on h, and always take k for what it is. So that's how we find the vertex. Once again, if your a value is positive, it's opening up. If your a value is negative, it's opening down. I hope this kind of gets you guys thinking of what we learned in the past, gets you guys more comfortable with it. Once again, the a value, if it's positive, it's opening up. If it's negative, it's opening down. And not only that, if your a value is 1, you could even use the pattern 1, 1, 2, 4, 3, 9 Now let's say you forgot about the pattern, and let's say that you did find the vertex +3, +1, which is right here. Let's say you wanted more coordinates. Well, you could always go to an XY table and plug in some numbers like 0. If you plug in 0 into the original, you're going to have 0 here. It's going to be -3 squared. -3 squared is 9. 9 times 1 is still 9, plus 1 is 10. So 0, 10 is actually a coordinate. So if you knew that the vertex was here and you forgot about the pattern and you actually went to 0, 10, that would mean 0 on the x, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You put a dot up here, right? And then you would know that this parabola has to be connected and map this dot over to this other side. So it really becomes super easy to graph these guys, to think about parabolas, if you understand a vertex form. And this is something we need to memorize, guys. Y equals a parentheses x minus h to the second power plus k. Let's take a look at the homework for today that the sub should pass out for you. This first part says, write each equation in vertex form, then identify the axis of symmetry and the direction of the opening. Okay, so let's zoom in on number 1. So this is in standard form. We want it in vertex form, and there's different ways of doing this. Now you could complete the square, but I'm thinking it might not be that good to complete the square because we have such huge numbers here. What I'm going to choose to do is treat this like if I were graphing it the old way. And what do I mean by that? The vertex, we're going to find that coordinate by doing x equals -b over 2 times a. Okay? So anyhow, what is this vertex? It's going to be -24 over 2 times a, which is -6. So let's plug in our b value, which is -24, and our a value, which is -6. Okay. Sometimes completing the square works out great, but right here, let's just go with the old method. Let's find the vertex. So this will be +24 over -12, which means that ends up being -2. Now we just found the x, so the vertex x value is -2. How do we find the y value? You simply go back up here and you plug in your -2 into your x positions. About the mess right here, but I did rewrite this guy but with parentheses instead of x's. That way I could plug in my -2 for x. So I'm going to plug in my -2 in here, my -2 over here. I will have an exponent, -2 to the second power, that's 4, so I really have -6 times 4 minus 24 times -2 minus 25. So -6 times 4, that's -24, and -24 times -2, that's a +48. Bring down the -25, and then 24 plus 48, that is +24. Then minus 25, we end up with a -1. Okay, so what we found was the y value, -1. Okay, so we have the vertex. Now, that wasn't that hard. We've done that in the past. Now, they want us to rewrite it in vertex form, okay? So, what is vertex form? Vertex form is y equals a parentheses x minus h squared plus k. You have to memorize it. Now, what is the a value? Well, the a value is the same as the a value in standard form. Okay? If you look up here, this one's in standard form. What's the a value up here? Is -24 the a value? No. Is -25 the a value? No. -6 is the a value. So right here in the vertex form, it's also going to be -6. So I have y equals -6 is my a value, parentheses, x minus h, I'm just going to leave a blank spot, squared, plus k. I'm going to leave a blank spot. Now we said that our h and k values are our vertex. And we have the vertex up here. So the vertex is simply h is -2 and k is -1. So yeah, h is -2. Let's plug that in right here. And when I plug it in, notice that the minus minus is going to change to plus plus. Okay? Once again, once you're done with it, let's think the h value what you see in here should be opposite of what you see right here. So this is a negative 2. Right here you really have a positive 2. So it makes perfect sense because it's a minus h inside the parentheses with x. Now the k value, take it for what it is. It's a plus k. And the k value is up there on your vertex. So once again, your vertex is your h and your k. So in this case, our k value is negative 1. And because vertex form has k as plus k, you're just going to put plus negative 1. So ladies and gentlemen, this is our vertex form quadratic equation of number 1. Okay, and that's what they're asking us to do vertex form. And then they want you to identify the vertex. Well, we already did that. We found that the vertex was negative 2, negative 1. Then it says identify the axis of symmetry. The axis of symmetry, remember, is your x value. Okay, so let's jot that down. Axis of symmetry is really x equals, and it's simply your x value of your vertex. Okay, x value of your vertex. So where did I get this x equals negative 2? Because the vertex has a negative 2 for your x. So the axis of symmetry is x equals negative 2. What else does it ask us to do? And the direction of the opening, well, that's super easy. Is this parabola going to open up, or is it going to open up, or is it going to open down? If your a value is negative, it's going to open down. Okay, so we answered all the questions to number 1. A lot of times completing the square works out great, but in this case, I think it's easier to just find the vertex using the old method, x equals negative b over 2a. Plugging it back in to find your y value, then you have your h and k value that you could plug in right here and here, and your a value on your vertex form is the same a value as your standard form, so just bring that a value down. It's really that easy. Let me try to do number 4 with the completing the square method. So one thing that we could do is simply make space for our new c value. The a value is already 1, so let's make space for our new c value. Now normally I subtract 20, move it to the other side, but you know what I'm going to do this time? I'm going to just move it over and make some space. Check it out. I know this might weird you out a little bit that I didn't move the 20 over to the other side, but just bear with me for a little while. Let's take half of 10 and square it to find that perfect c value, okay? So half of 10 is 5. 5 squared is 25. Let's put plus 25. Now, think about what just happened here. I have an equation. Here's my equal sign. Y equals all this stuff. What did I just do? I added 25 to the right side of the equation. Now, you can't just magically add 25 because it's not going to be balanced anymore. So one option is to add 25 over here, or this is the new trick I'm going to show you, subtract 25 from the same side. Again, we added 25 here by getting that perfect c value. Half of 10 is 5. 5 squared is 25. And I subtracted it to maintain the balance. It's like having plus 3 minus 3. It balances out. So plus 25 minus 25. Now why would I do that? Because right here I now have a perfect square quadratic trinomial that I could write as a binomial squared. And of course, what's inside with the x? Half of b, which is 5 in this case, okay, because half of 10 is 5. And what about the k value over here? 20 minus 5 minus 25 is minus 5 at the very end. And guess what, guys? You have rewritten it in vertex form using completing the square method.